Good morning, everyone, and welcome to our hearing on marine and hydrokinetic energy technology, finding a path to commercialization. In today's hearing, we'll explore the role of the federal government and industry in developing technologies related to marine and hydrokinetic energy generation. These technologies include devices which harness energy from waves, tidal, ocean, and river currents, and ocean thermal gradients. Development of related environmental monitoring technologies is also critical for appropriate implementation of these emerging technologies. Studies have estimated that approximately 10% of U.S. national electric demand may be met through energy generation from river in-stream sites, tidal in-stream sites, and wave generation. This projection does not include ocean thermal energy, ocean currents, or other distributed energy generation from man-made water systems. While there's a huge potential for energy from these technologies in the U.S., the U.K. has been referred to as the world leader in ocean energy development by the International Energy Agency and the Electric Power Research Institute. The world-renowned testing facilities of the European Marine Energy Center are at the forefront of technology development and are the premier test bed and information center for policymakers, academia, and U.S. companies with new technologies. The U.S. became involved in marine renewable energy research in 1974 and enacted 2 laws on ocean thermal energy in 1980. The Congress did not authorize significant research on these technologies until the Energy Independence and Security Act of 2007. Since then, DOE has built up a modest portfolio of marine energy R&D activities within the wind and hydropower program of the Office of Energy Efficiency and Renewable Energy. This program has received a small amount of funding and issued a variety of small awards to fulfill its statutory obligations. In my own home state of Washington, DOE has funded Open Hydro, a tidal technology developer based in Ireland and selected by the Snohomish County Public Utility District to design and install a tidal energy pilot plant in Admiralty Inlet. I'm glad we have a representative of Snohomish here with us today so we can hear about this project, which is expected to begin operation as early as 2011 and produce up to 1 megawatt of energy, enough to power roughly 700 homes. With few exceptions, marine and hydrokinetic technologies will need to be competitive in the marketplace if they are to be widely deployed. Therefore, I am especially interested to hear from our witnesses about the current and projected costs of electricity generated from marine and hydrokinetic technologies and how a more robust federal program might help in bringing these costs down. With that, I'd like to thank our excellent panel of witnesses who we'll hear from in a moment. At this point, I recognize the distinguished ranking member, Mr. Inglis, for his opening remarks.
Thank you, Mr. Chairman, and thank you for holding this hearing. This is a timely hearing. This year we've held hearings on solar, wind, and biomass energy sources. Hydropower contributes more renewable energy to the U.S. electrical grid than all these other renewable sources combined. Depending on rainfall and water storage, conventional hydropower accounts for 6 to 9%. That's 6 to 9% of the total U.S. electrical supply. Today we have the opportunity to explore ways to increase the contribution from hydropower through unconventional water sources. Marine-based hydropower represents a significant source of unused energy. South Carolina has a coastline of nearly 200 miles and considerable tidal resources around the Sea Islands. Technologies that can take advantage of the waves, currents, temperature differences, and tides can turn our abundant coastal and tidal zones into energy generators. As we'll hear from our witnesses, these technologies will face a number of challenges related to environmental conditions and competition with recreational and commercial activities. I'm confident, though, that we can manage all these challenges to utilize this large potential energy source. Microhydro represents a great opportunity for distributed electricity generation in streams and rivers, irrigation canals, and other bodies of water previously not considered powerful enough for power generation. Hydropower installations of 1 megawatt or less can be deployed across the country, easing the burden on our electrical grid and increasing the security of electricity users around the country. I'm looking forward to hearing from our witnesses today on the current state of these technologies, what we need to move forward, and what role the government should play in removing barriers to development and installation. Thank you again, Mr. Chairman, and I yield back.
Thank you, Mr. Inglis. We have been joined by Dr. Ehlers and also by Mr. Smith from Nebraska. I'm always glad to see someone from Nebraska here at a tidal energy thing. It shows that the concerns about global warming must be real. If we're planning on tidal energy in Nebraska, we've got problems on our hands. But good to see you, Mr. Smith. Thank you for he's an excellent member of this committee and glad to have him here. With this, we'll hear from our witnesses. Mr. Jacques Beaudry-Losique is the Deputy Assistant Secretary for Renewable Energy at the Office of Energy Efficiency and Renewable Energy for the U.S. Department of Energy. Mr. Roger Bedard is the Ocean Energy Leader for the Electric Power Research Institute. Mr. James Dehlsen is the founder and chairman of Ecomerit Technologies, LLC. Ms. Gia Schneider is the Chief Executive Officer of Natel Energy. Did I skip somebody? Oh, okay. And I'm sorry. And I will. We were hoping Mr. Inslee would be here to introduce Mr. Collar, but I get the pleasant duty of doing that from my home state. Mr. Craig Collar is the Senior Manager of Energy Resource Development for Snohomish County PUD, or SNOPUD, as they sometimes call them. I think Snohomish PUD is a better deal. Beautiful county and great tidal resources there if we can figure out how to harness them. So an outstanding panel of witnesses. As our witnesses know, you'll have 5 minutes for your spoken testimony. Your written testimony will be included in the record for the hearing. When you have completed your spoken testimony, we'll begin with questions. Each member of our panel will have 5 minutes to question witnesses. With that, we look forward to your testimony. Thank you again for being here. Mr. Beaudry.
Chairman Baird, Ranking Member Inglis, and Subcommittee members, it is a pleasure to testify this morning. And thank you for your leadership in bringing these important marine and hydrokinetic energy technologies to the attention of the American public. The Department of Energy shares your belief that these technologies have significant potential to contribute to the nation's future supply of clean, cost-effective, renewable energy. Studies conducted by the University of Washington, Virginia Tech, and the Electric Power Research Institute estimate that approximately 400 terawatt-hours per year can be extracted from marine and hydrokinetic technologies in this country, excluding ocean thermal systems. This is enough electricity to power cleanly approximately 36 million average American homes. The Department of Energy's Office of Energy Efficiency and Renewable Energy has allocated a substantial portion of its congressional appropriations for water power toward the support of marine and hydrokinetics project. In fiscal year 2008, $9.1 million supported 14 marine and hydrokinetic projects. In fiscal year 2009, funding more than tripled to $31.3 million, which supported a total of 41 separate projects. And in fiscal year 2010, we expect approximately $35 million to support marine and hydrokinetics projects. The Department provides needed research and development funding for the industry, which is still at a relatively early stage of development and includes many small firms. Only one commercial project is currently operating in the U.S., a 100-kilowatt in-river turbine on the Mississippi River in Hastings, Minnesota. Therefore, much of the work the Department funds focuses on 2 major priorities. 1, assessing the nation's resources, and 2, determining baseline and potential future costs of energy through analysis and testing of device performance and reliability, and the extent to which there are environmental impacts associated with these technologies. In order to monitor this developing industry, the Department recently created an online database for devices under development. This database provides detailed information about the testing and deployment of these technologies around the world, even though the majority of development is occurring in Europe, North America, Japan, and South Korea. The database currently tracks 149 companies working on a 123 device, which demonstrates that no firm industry consensus exists as to which technology will perform most efficiently. In fact, technology selection is highly dependent upon regional factors. We segment the marine and hydrokinetic industry into 3 major categories. 1, wave energy. 2, current, such as ocean, tidal, and river. And 3, ocean thermal energy conversion, or OTEC. In the first case, the U.S. has experienced significant growth in the wave energy industry in the last decade, and there are currently more than a dozen domestic companies and developers in existence. The size of the domestic resource has encouraged the development of this technology, particularly in the Pacific Northwest. Second, the Department is committed to working with industry to develop ocean, tidal, and river current technologies. For example, the Department recently made awards to develop the first drivetrain uniquely designed for large ocean current design devices and for a pylon-based mooring system to increase the efficiency of in-river turbines. The Department also funds a number of projects in one of the most promising areas in the country for the development of tidal energy, the Puget Sound in Washington State. For the past year, DOE and the Snohomish County Public Utility District have jointly funded the initial survey, siting, and permitting work necessary for the construction and installation of up to 3 turbines at a tidal energy pilot in the Admiralty Inlet west of Whidbey Island. Third, ocean thermal energy conversion systems use the ocean's natural temperature to generate power. OTEC could produce significant amounts of alternative energy for tropical island communities that rely heavily on imported fuels. The department is currently assessing OTEC life cycle cost, testing new manufacturing methods for cold water pipes, developing a national resource assessment, and evaluating specific environmental impacts associated with large water intake systems. Furthermore, to help achieve program objectives, the department created and currently utilizes national marine renewable energy centers. The centers are partnerships with the goals of promoting research, development, and deployment of marine energy technologies. In 2009, 2 centers were formally established, one at the University of Hawaii and the other as a partnership between the University of Washington and Oregon State University. The department is pleased with the progress that has taken place at the centers since their recent inception. As an aside, next week I will visit the Pacific Northwest National Lab's SQUIM marine research facilities, which work in partnership with the centers. Finally, to enable market development, the department collaborates with the International Electrotechnical Commission to develop codes and standards for all 3 groups of emerging technologies, as well as with the international energy agencies to create a worldwide database of environmental research and best monitoring practices for these technologies. Looking to the future, the department is currently developing an industry roadmap. This effort will identify the various barriers that limit progress and highlight the technology developments, policies, and other activities necessary to overcome these barriers. The first step is essential to ensure that marine and hydrokinetic power can become another significant resource to the nation's clean energy portfolio in the long term. So thank you again for the opportunity to appear before you today to discuss these important issues, and I'm looking forward to answer any questions.
Thank you very much. Before we proceed to Mr. Bedard, I want to briefly note that our colleague, Representative Inslee from my home state, Washington, has joined us. Mr. Inslee has introduced legislation pertinent to this topic, and without objection, I'd like to ask my colleagues that Mr. Inslee be allowed to join us on the dais. Hearing no objection, thank you for joining us, Mr. Inslee. With that, we'll proceed to Mr. Bedard.
Thank you, Chairman Baird, Ranking Member Inglis, and members of the committee. Again, my name is Roger Bedard. I'm the Ocean Energy Leader at the Electric Power Research Institute, a collaborative nonprofit R&D organization. We appreciate the opportunity to provide testimony to this committee on marine and hydrokinetics, or MHK, technology, the pathway to commercialization. In 2004, we initiated wave energy technical and economic feasibility studies. In 2006, we followed that up with tidal hydrokinetic feasibility studies, and in 2008 with river hydrokinetic studies in the state of Alaska. Our studies have resulted in a substantial momentum, nationwide momentum, towards adding MHK technologies to our national portfolio of energy supply alternatives. One measure of this momentum is the number of preliminary permits filed to the Federal Energy Regulatory Commission by private investors that reference the EPRI studies. I will focus my comments today on 4 key points. First, the wave and tidal hydrokinetic energy resource available to generate electricity in the United States is significant. Second, the technology to convert these resources to electricity is emerging and ready for testing in the ocean. Third, wave and tidal hydrokinetic energy can be cost competitive with other renewable technologies in the future. And fourth, significant challenges remain to finding the pathway to commercialization of MHK technologies. Our studies indicate that total recoverable ocean wave and tidal energy resource could enable electricity generation on the order of about 10% of the present electricity consumption, and that turns out to be about 400 terawatt hours per year. The most significant of these resources is wave energy, and the locations with the most economically viable wave energy resource is Hawaii and the Pacific Northwest. It's important to understand, though, that many factors may limit the use of this technology, including electrical transmission capabilities, environmental concerns, and societal considerations. There are many technology companies at various stages of development. The development cycle for these technologies is typically 5 to 10 years. While there are now many companies ready for prototype testing in the ocean, only a few have reached that stage of development. As wind technology was beginning to emerge into the commercial marketplace, the wholesale cost of electricity was in excess of 30 cents per kilowatt hour. That's in 2009 dollars and with no government financial incentives. Technology improvements and learning through production has cut that cost to about 7 cents per kilowatt hour today. Our studies indicate that MHK technology will enter the marketplace at a lower entry cost than wind energy did and will progress down a similar learning curve. The key reason for that is the high power density of the MHK resource compared to, say, the wind or solar resource. Now, on the other side of that coin is a challenge. The challenge for the industry is to develop cost-effective deployment and operation and maintenance technology given the remoteness and at times hostility of the operating environment. We believe that a robust electrical system of the future will have a diversified portfolio of energy supply alternatives. Our nation has investigated all known electricity supply alternatives except for one, the ocean. Our oceans are a public resource accommodating multiple uses, including the marine life, fishing, shipping, and recreation. Ocean energy could work in harmony with those other users and provide renewable energy for the overall good of our society. It will take a sustained evolutionary effort over the next 20 years to perfect MHK energy technology. We need to build the capability in this country to design, analyze, fabricate, test, and deploy these emerging technologies. In the area of testing and test facilities, currently the U.S. marine energy industry is challenged by the lack of proper and standardized infrastructure to deploy and test devices in the ocean. We're starting to make progress. The Northwest National Marine Research Center, led by Oregon State University and University of Washington, will provide ocean energy conversion system test berths for developers to perform ocean testing. The Pacific Gas and Electric Company is developing a pre-commercial demonstration test facility known as Wave Connect for system testing, full system testing of arrays or farms of these devices. Long-term and consistent government funding support through this high-risk research and development and demonstration period is essential for building a globally competitive commercial U.S. industry. The idea of harnessing the vast power of the Earth's oceans has fascinated and tantalized humans for centuries. Today, we may be on the cusp of realizing these potential MHK technology options that we expect will prove tremendously valuable to our nation in a carbon-constrained future. Thank you.
Thank you, Chairman Baird, Ranking Member Mr. Inglis, and members of the committee. My name is Jim Dehlsen. My work has been in renewable energy technology since 1980, mainly focused on wind turbine design, manufacturing, and helping to build the industry. The companies I formed and led are today America's 2 wind turbine manufacturers of utility-scale power generation, the wind division of General Electric with roots going back to Zahn Systems, which I established in 1980, and the second, formed in 2001, is Clipper Wind Power. I can state from this experience that both of these turbine manufacturers would not exist today had it not been for the enlightened U.S. energy policy stemming back to the oil embargo in the 1970s. Since 1999, I've also been engaged in marine renewable energy and recently formed Ecomerit Technologies with my son Brent to advance electric power systems based on wave and ocean currents. My wife tells me I flunked retirement. I've been asked to address 3 items: advancing marine renewable energy as a separate program from hydropower, the expected time for marine energy to reach commercial readiness and large-scale deployment, and the DOE industry partnership in wind technology and implications for marine renewable energy. First, hydropower and hydrokinetic have little in common. The basis for establishing a marine hydrokinetic program separate from hydropower is based not only on major differences in requirements for offshore marine versus land-based system deployment and operation, but also very different technical, financial, and technology maturity characteristics. These 2 hydros have little in common, Advances in the new marine technology will be far more robust and will occur more quickly and with marine hydrokinetic program apart from and not under the federal hydropower program. Second, the cost of energy and deployment. For a decade, I've engaged in an effort to advance utility-scale power generation technology for both wave energy and ocean currents. Based on our engineering, we're targeting a cost of energy for both technologies in the range of 10 to 12 cents per kilowatt hour by 2015, a level that should enable early commercialization, provided the U.S. government implements an effective program of incentives that supports marine renewables more tangibly and consistently than the federal support for wind energy. We're expecting early systems to be megawatt-sized, therefore meaningful rates of deployment, several thousand megawatts per year, should come in the 2015 to 2020 timeframe, in line with a forecast potential of 23 gigawatts by 2025, which was a recent estimate by ACOR. While this appears quite accelerated when compared to the history of wind, solar, and other renewable energy technologies, it must also be viewed in light of the advanced know-how which is brought forward from marine engineering and shipbuilding, offshore oil, submersible vehicles, knowledge we now have on structural loads and control systems of wind turbines, the advanced numerical model design tools, and fabrication know-how in large composite structures. This substantially reduces development costs and timelines. Furthermore, the urgency that is now upon us from climate change and energy security is driving development of marine renewable energy, not just in America, but Europe as well, now with several years lead, so we can expect a fast and competitive pace of technology advancement. Learning from wind power. The U.S. renewable energy experience shows that in a government-industry partnership, the fundamental factor for success is a sustained federal commitment in the face of change such as global price fluctuations or shifting national priorities that come with each administration or political appointee. Perhaps the hardest public policy lesson that's come out of the American wind effort has been the repeated crippling effect on the industry from discontinuity in government support. The U.S. was in a clear leading position in wind power in the early 1980s due to early support, which gave birth to the industry. Government support ended later that decade in the U.S., and the wind industry virtually collapsed. A series of on-again, off-again programs followed. While the U.S. wind industry continued in its struggle for survival, strong European Union support stimulated rapid growth throughout the continent. Today, European companies enjoy the lion's share of the industry, creating several 100,000 jobs, generating upwards of $40 billion a year, and growing at 20% plus annually. Now we're seeing massive support for wind energy in China, which has initiated 10 separate 10,000 megawatt regions representing $200 billion in industrial activity, fully supported by the central government. While America had the foresight and made the investment to launch the wind industry, discontinuity in this support has allowed other nations to capture a major share of the long-term industry and energy benefits. We must not let this happen with marine renewables. Government support should be implemented quickly and sufficiently to sustain this emerging industry until it reaches industrial scale. Thank you.
Well, good morning. Thank you, Mr. Chairman, Ranking Member Inglis, and members of the committee. Again, I'm Craig Collar from Snohomish County Public Utility District. Snohomish PUD is, of course, located in Washington State, just north of Seattle. We're the 12th largest public utility in the country, and we certainly appreciate the opportunity to provide testimony on this important topic today. Well, as you're all aware, the marine energy industry really today is in its infancy, and as a result, there's very little data available relative to the viability of marine energy moving forward. In our view, the best way to close that data gap is by the responsible deployment and close monitoring of commercial scale projects at appropriately selected sites. In fact, that's the very purpose and objective of our project in the Puget Sound. Our project is already recognized as one of the leading efforts in the country. We have an extremely strong project team. Includes the University of Washington, the Northwest National Renewable Energy, Renewable Energy Center, EPRI, 2 national labs, and of course the Department of Energy. Now, working with our partners, we've selected Admiralty Inlet as the most appropriate site for our project. And as you can see from the chart, Admiralty Inlet is the main entrance to Puget Sound, and it's important to note it's a very large body of water. It's nearly 3.5 miles across. In terms of tidal technology, we have selected Open Hydro as our partner for the project. Now, Open Hydro is an Irish company. They have licensed tidal turbine technology that was developed here in the United States. And they're one of the few companies in the world that have already deployed and tested large-scale tidal energy devices and generated some data and learning from those. In fact, one was deployed just last month in the Bay of Fundy up in Nova Scotia. The turbines utilized for our project will be very similar to those for that project, and in fact are similar to the ones shown in the picture that you see on the screen. I'll also take this opportunity to note that the rotor on this turbine rotates at a very low speed, only in the range of 10 to 15 RPM. Now, we intend that our demonstration project will consist of 2 to 3 of these open hydro turbines connected to the electric grid. The project will overall be a very limited scale relative to the size of Admiralty Inlet. In fact, it represents less than 0.05% of the cross-section of Admiralty Inlet. This figure shows to scale what a tidal turbine in a cross-section of Admiralty Inlet would look like. It's also important to note that Admiralty Inlet is the main shipping channel in and out of Puget Sound, so all commercial traffic, military traffic, naval traffic, all goes through Admiralty Inlet. So by any standard and definition, Admiralty Inlet is a working waterway. Lastly, this figure depicts a bird's eye view of 2 turbines to scale in Admiralty Inlet. Might be hard to make out, but the 2 small black dots that black arrow is pointing to, that's how large these commercial scale turbines would be in Admiralty Inlet. Well, to date, our project has been granted approximately $2.5 million in mostly federal funding and primarily from the Department of Energy. So the Department of Energy's support, both currently and ongoing, will be absolutely critical to our project. With respect to environmental considerations, one of the benefits of working with Open Hydro is they have actual data from deployments of these devices elsewhere in the world, primarily in Europe. And in fact, their projects there have been continuously videotaped since 2006, and to date have seen absolutely no interactions with fish or marine mammals in the turbine while the turbines are operating. In terms of permitting, we are utilizing the FERC pilot process for our permitting effort. This process was developed by FERC specifically to facilitate the licensing of small, short-term, removable, and carefully monitored projects just like ours, while reducing the baseline study burden, thereby facilitating getting these projects into the water so we can gather data. Over the past 3 years, we've conducted nearly 100 formal project communications meetings with over 50 various and different stakeholder groups, importantly including, of course, tribal governments and resource agencies. Now, one of the key challenges that we face with resource agencies in particular is balancing the small size and scope of our project with the level of baseline information necessary to support permitting. It's clearly recognized that if those requirements are too burdensome, pilot projects like ours will never be able to advance into the water, and progress in the U.S. will essentially be at a standstill. Now, we believe that some resource agencies perceive that their existing regulatory accountability really precludes their support of a pilot process type approach. For instance, National Marine Fisheries Service feels they have little latitude to accept anything less than very detailed and rigorous baseline studies in order to support their analysis. Well, in fact, we are conducting in the neighborhood of $1 million of pre-installation and baseline studies just for our small research and development project. And to date, National Marine Fisheries has been reluctant to state really with any certainty that even that will be sufficient. Because these studies represent a very significant cost in advance of any certainty of actually getting a license for the project, it's very easy to see how this could easily prevent even leading research and development projects like ours from moving forward. So in conclusion, it seems clear that so long as key resource agencies are not enabled to effectively balance the proactive facilitation of renewable energy with their existing responsibilities, the advancement of renewable energy in this country is unlikely to progress at a pace sufficient to meet our energy and environmental challenges. Well, thank you again for the opportunity to appear before you today. I certainly would be happy to answer any questions.
Okay, thanks very much, Chairman Baird, Ranking Member Inglis, and members of the committee. I am founder and CEO of a company called Natel Energy, and we are commercializing a new low-head hydropower technology that has the potential to cut the turbine plus generator costs of developing low-head projects by as much as 50%. And at the same time, we look to then enable safe downstream fish passage. So head is a term of art used in the hydropower industry to generally reference the amount of drop that you have available to generate energy at any particular site. And when we say low head, our particular focus is on sites that have greater than 5 feet but less than 20 feet of drop. The reason why we feel this is a really interesting place to focus is that there's actually quite a large amount of potential in low head in this country. According to a DOE study that was done back in 2004 that categorized separately low head versus high head potential in the country, there are about 71 gigawatts of remaining undeveloped low head potential in this country. And in comparison, that represents less than 2% of the total that has been developed. There's about 73 gigawatts total, and about 71 remains to be developed. That study actually did not even quantify an additional important source of low-head hydropower that exists within our existing man-made structures, like irrigation districts, conduits, and canals. There are thousands of miles of these existing canals across, primarily in the western U.S. These canals all have thousands of existing drop structures. Those drop structures were built specifically to dissipate energy to help make sure that the water velocities in those canals remain within the operating constraints of the canals. That's the place where we could actually, in a pretty straightforward fashion, if we had effective technology, retrofit those sites to capture energy and bring that energy onto the grid. The technical challenge is that when the amount of power that you can generate at any given site is defined by the amount of head and the amount of flow. And the particular technical challenge that has prevented the development of low head in this country so far is that the technology that exists today is just very expensive. When you get down to heads that are less than 20 feet, the design constraints mean that using conventional technology just becomes way too expensive to develop these sites. And so that's where we focus most of our innovation. There also are environmental concerns that have to be addressed. And just because you have a site that has a small amount of power output or is low head in nature does not necessarily mean that these sites are low impact. So therefore, responsible siting is absolutely a factor. This is actually where we think man-made conduits and canals could play a really interesting role going forward, because in a lot of those settings, you incur very minimal incremental environmental impact to develop those sites. Many of those low existing drops are close to roads, close to transmission lines. It doesn't require getting major new transmission infrastructure to be able to bring this power online. When you move out of existing canals and move into streams, your environmental issues absolutely do go up. So when we look at the 40,000 existing low dams in this country, most of which also don't produce power, we have to start to look much more closely at environmental issues with respect to stream fish passage and water flow level fluctuations. This is also an area where development of monitoring technology and tools and R&D support into quantifying the environmental impacts of putting low-head hydropower on these existing structures would be very valuable. Beyond that, when you start to look at putting multiple installations in series, multiple low-head installations in series, looking at multiple low-head dams on a particular river or stream, the combined impact of those installations also has to be evaluated. And that's another very important area for focus for environmental impact study and research. So what are some of the ways to catalyze innovation in this space? Well, we actually have received a DOE Phase 1 SBIR grant from the latest stimulus bill funding round, and we will use that to focus on optimizing blade design in our turbines going forward. This kind of support is absolutely critical. The technology that we're developing is actually coming in at an entry cost point that is pretty cost competitive already. Right now we look at about 8 cents a kilowatt hour. So we're already down, well within the range of where we can start to actually develop sites today. At the same time, we think we can get that down to about 5 cents a kilowatt hour. And further support from the DOE, further grant support to look at R&D specifically into components to make this technology and technology such as ours more cost effective would be greatly used. I think the bigger barrier is actually coming on the environmental side. So on the in-conduit and in-canal man-made canal systems area, The challenges are a lot less from the environmental side, and the environmental impacts are within ones in which, at least certainly as we're finding, talking to irrigation districts, we can start to get a handle on a lot of that. But as we look to move into streams, the studies that need to be done to effectively go through the licensing process to make sure that these sites are chosen responsibly and to provide the data that's necessary in the licensing process becomes a lot more great. The burden becomes much greater. And so this is an area where we think additional funding through the DOE or through other programs that could focus on helping to collect standardized environmental impact assessment data and make that data available would be very useful. Finally, as private companies such as ourselves and other companies in this space, in the hydrokinetic and also in marine technology space as well, a lot of us are spending a fair amount of our own dollars doing a lot of these kinds of environmental assessments. And so some form of incentive in the form of perhaps a tax credit could be very useful. It would help us. We're going to go forward. We have, we make the business cases to our investors to invest in this technology as they look forward to the role that these kinds of technologies could play in addressing our clean energy future. We are gathering private support, but at the same time, if we could recoup some sort of return or some sort of offset for that investment that we are making on our own, that would be helpful in itself. In summary, a little bit different from the focus for the rest of the panel. Our focus is specifically to talk about low head potential. We believe low head hydropower is actually the low-hanging fruit, one of the true low-hanging fruit renewable energy opportunities in this country, where we can bring distributed renewable baseload power online relatively quickly. Thanks very much.
Thank you very much, Ms. Schneider. Excellent testimony, as not surprising given the backgrounds of the distinguished witnesses. I'll recognize myself for 5 minutes, and then we'll proceed in alternating order. We've been joined by Mr. Davis, Mr. Tonko, and previously, oh, there he is, the #1 expert on wave energy in the U.S. Congress, Mr. Rohrbacher. I say that because he's our surf advocate. I guess I hear that Bill Bray's a better surfer, however, but he's very passionate about the ocean. A number of questions come up, more than I could possibly cover in 5 minutes, but I'll start with a few. One of the issues is very troubling. Mr. Dehlsen, you talked about it. Mr. Bedard, you alluded to it. I'm so frustrated to see U.S.-developed technology, consistently the initial technology developed here and then capitalized and engineered elsewhere and then manufactured elsewhere. We're seeing it here again, apparently. One of the limitations, in addition to some of the environmental issues that Mr. Collar and Mr. Schneider mentioned, seems to be that the test beds right now are elsewhere. If we don't have yet, that I know of, in place on either coast, a reliable place where if I'm a manufacturer of some equipment, I can say, okay, I'm going to work with FERC and DOE, we're going to ship it out there, drop it in the water, and see what it does. What's being done to do that? Mr. Bedard, you talked about some potential facilities, and what's being done, and how is the government helping with that at the federal level, and what can we do better?
What's being done?
Make sure your mic's hit.
I have to hit talk. Sorry. What's being done is that just last year, I'm sorry, I'll take that back. The FY08 appropriation initiated some national marine energy centers, specifically Oregon State University on wave, University of Washington on tidal, University of Hawaii on both OTEC and wave, and Florida Atlantic University, I believe, is receiving an earmark on ocean currents. So this country, we're just starting. Europeans are 10 years in front of us. Their governments have established test facilities, have been in place now for more than 5 years. So we've started. What we need is, as I said, consistent, long-term, sustained support to these test facilities, so that way developers do have places to go and put their machines into the water and develop the technology as step one. And then once that prototype gets developed, we then need to have systems test facilities, much like PG&E and Snohomish are doing, with a fully integrated grid-connected array of systems.
When will we have these test beds ready to go?
It's a number of years away. It's really uncertain because of the regulatory issues associated with it. We have to even permit these test beds. And so there's uncertainty in terms of when. There's literally dozens of regulatory agencies that have to be dealt with.
Okay, that's very helpful. That's kind consistent with the concerns of Mr. Collar. Mr. Collar, let me follow up on that regulatory issue, because it seems that the test bed issue, as I've read your testimony and listened to you, it seems that this test bed issue is central. Mr. Dehlsen talked about the reliability of funding. You know, this annual extension of the production tax credit's not going to cut it. We need a sustainable, predictable capital situation, including tax incentives. But this regulatory environment issue is very, very central. Talk to us a little bit about what you think we ought to do, Mr. Collar.
It really is one of the key challenges to moving these kinds of projects forward, and I think a lot of it is because really, again, that lack of data. It's very much a chicken or the egg kind of a situation. It's difficult to get projects like this permitted because there's no data, and you can't get the data because you can't get the project permitted to get it into the water to generate that information. So I think, again, it's finding ways to strike that balance within the agencies between the facilitation of renewable energy and fully meeting their existing responsibilities and accountabilities. Now, one of the ways that we seek to do that with our project is via the very small contained scale of the project. We wouldn't advocate, nor would anyone else that we're aware of, you know, the installation of many, many turbines in a place like Admiralty Inlet before we've first installed one or two and learned from those devices. But until we do that, and until we can do that in a reasonable way in terms of both cost and resources and effort, it's going to be very difficult to move beyond that stage. So I think one of the things is to come to grips or gain good alignment with the agencies around, you know, what is an appropriate amount of risk to take with some of these early projects. The experts that we talk to in the Puget Sound would say the risk of our project is almost vanishingly small, but it's not zero. And I think that sometimes the agencies really have discomfort until they could really see zero risk.
Are you dealing with ESA issues? I mean, is this a, you know, the question for me is, so what's the problem? You know,
yeah.
Given the model you talked about and the tiny scale, and I understand the baseline data. I'm proud to be a scientist and happy to be on this committee, but what is it I've been told you have to have at least a year of baseline data before you put something in the water. Is that accurate?
At least a year. In fact, there certainly has been pressure to have much more than that, and it's also a degree of to what level of detail the data needs to be. I mean,
what's the specific concern? Is it we just don't know what the concern is because we haven't done it yet, or are we saying, well, we're expecting salmon or sturgeon or groundfish, or what's the story?
The most specific and the largest concerns in Puget Sound and Admiralty Inlet in particular are the effects of installations like this on ESA-listed species, particularly orca and salmon.
Orcas.
Those are the key species. So really that's the question that we're grappling with now, is what's the right degree of information in terms of the current behavior, abundance of salmon species and orca in Admiralty Inlet. And of course there's a lot of information, historical information available relative to those questions, so it's really how much more do you need before you could go forward with a project like the one we propose. Gotcha.
Ms. Schneider, you know, I grew up in canal country where western Colorado was irrigated, and we used to boogie board on those canals. Pretty dangerous. Periodically, one of our friends would disappear. It was kind of a bad deal, but it seems to me that there's a lot of potential for this. Have you actually got? Is this sort of just a more efficient turbine design? I don't remember seeing in your testimony a picture. Maybe it's proprietary and you don't want to share it with us lest we branch out in new career paths. But
No.
What does this look like?
It actually doesn't look like any kind of conventional rotary turbine that you've seen. It's the technical term for it would be called a two-stage fully flooded impulse turbine.
Oh yeah,
technical term, yeah. So, anyhow, no, but so it is a new turbine. It is a new turbine design, and the specific aspects of it are basically as very simple blades, which kind of allows to drive down costs. So cost of manufacture is a lot lower than conventional reaction turbines, the other conventional technology, and at the same time the generating side is the generator interface is fairly efficient because it actually has a fairly, what's called a high specific speed without getting into too much technical term art. Anyhow.
Vern will explain all this later to us. Vern's still here? Yeah, good, we're okay.
But we have an installation that's going forward actually with an irrigation district in Arizona. We just started installation at the beginning of this week. So we've been through the FERC exemption process, received the FERC exemption in September, and that should be online and generating electricity hopefully in January.
That's exciting. Thank you. I recognize Mr. Inglis for 5 minutes.
Thank you, Mr. Chairman. I found it interesting that Ms. Schneider and Mr. Collar both spent some time discussing the impact on species. It's worth paying some attention to that. It's also worth paying attention to, if you consider the ocean acidification problem related to the incumbent fuels. They're trade-offs in life, and we should put pedal to the metal, and should. That's the way we say it down in South Carolina.
That's right, good.
That's right, good. That's right. So it is interesting that both of you spent considerable time trying to allay those concerns, but if you compare it to the other concern, it's really rather small. So pedal to the metal. Mr. Dehlsen, happy that we're the happy beneficiaries of all your work. I didn't realize we had you to thank, but I thank you for having General Electric is in the district that I represent, where it makes wind turbines, and we have 1,500 engineers and 1,500 production people that some which work on wind, some on gas turbines. But so you're the father of that, and we thank you. For any of you, what do you think about the possibility of combining wave barges with wind barges, such that you get a twofer out of the lines, I guess, running back to shore? Is this possible?
We are looking at that actually for projects in the UK. Clipper Wind Power is currently in advanced engineering on a 10-megawatt offshore wind turbine, and for deployment in UK waters. And we believe that for every turbine that goes in, we could probably deploy 3 wave devices of the type that we're in design on. Those are each 4.5 megawatts. So for every 10 megawatts worth of infrastructure that you're putting in, you'd pick up another 13.5 megawatts of wave energy. We think it's quite a nice way to bring down the cost of energy by combining the two technologies.
I suppose, in part, what you're doing in some of those designs is using the weight of the apparatus, right, as the tide drops to move turbines or something, so that you basically end up getting a benefit from the weight of all the stuff you got up on top doing the wind. Have I got that right? Is that one of the designs?
There are designs like that. Ours is one where between the turbines, which are centered on about 1,200 meters, you would accommodate 3 of the what we call the centipod wave generators, which are very long barges. They're about 650 feet long and have 56 pods on each side, so they are fully exposed to the wave front and can yaw into the wave front. It's quite an unusual design, actually.
So you use the motion through that barge apparatus to create the energy?
That's right. Mm-hmm. It's through the pods moving up and down, while the barge itself, it's really not a barge, it's a lattice, open lattice structure that allows the wave to pass through it as the wave, and as the wave passes through, it causes the pods to go up and down, drive hydraulic fluid to drive a hydroelectric system.
Yeah, interesting. Mr. Papar.
There is also another benefit, in addition to the cost twofer that you mentioned, and that's the fact that you have 2 resources that have variability to them. Yeah. And you put those 2 together and you get less variability. There are less number of hours with no resource available when you have a hybrid wind wave system than either a single wind or wave system. I tried to sell one of our EPRI feasibility studies a couple of years ago on that very topic, and was told by all of the state energy agency and utility potential clients that I tried to sell that I was 25 years ahead of my time.
Yeah. Of course, the thing that I hope that you're prophetic there, and maybe ahead of your time, but hopefully people will catch up with you, is that it's the economics that will drive this. If it's economically viable, then it'll be deployed. I learned a great new definition of sustainability from an entrepreneur in Spartanburg, South Carolina, who recycles PET to make bottles again. He says the definition of sustainability is making a profit. And I think that's a very good definition. If you can make a profit, it's sustainable. If you can't, it is not. And so that's what we need to be focused on, is figuring out how you can get 2-fers or 3-fers so that it makes sense economically. Thanks, Mr. Chairman.
Thank you. Recognize Mr. Who's on deck? Mr. Davis, next in line. Thank you.
As we engage in this debate that we've had for some time on all different types of sources of energy, and we continue to find new sources that we believe will be alternatives and renewables and less expensive, oftentimes we don't compare the cost of the current methods of producing energy and are cleaning up maybe some of those pollutants that we have, such as coal, or look at natural gas, or look at other sources. We seem to get a great deal of excitement about sources of energy that may or may not produce an abundance of, or at least close to the same amount of energy for a similar cost as what we produce today. So I think that as we engage in this conversation, the hearings we're having today, is certainly good for us, this nation, to be having these hearings. But I would like to hear more from each of you. When you take a kilowatt being produced today, what would it cost for the same, and how quickly can this be put online to where we start using this to benefit economically and job creation? How quick can this happen? How soon can we expect to see benefits from this, and how costly will it be compared to what we're producing today? And that's basically my comment that I want to make. Does anyone want to have, can anyone answer that question?
Thank you for your question. I would say it's fairly important for us to always consider a balanced portfolio of technologies, some of those being nearer term and being able to deploy and make a difference. And we're working on some of those, like, for example, at DOE, like land-based wind, for example, and some elements of solar technologies. It's also important to not neglect longer-term, very large sources of energy that could also make a difference 10, 20 years from now. And I believe this is part of one of the roles of government. Some of these resources could include offshore wind and some of these marine and hydrokinetic resources. And I think the question is, how do you strike the right balance between near-term technologies that can make a difference and long-term, very large-scale source of technologies? And I mentioned a couple here. And also, how do you compare these technologies to the cost of existing technology? Will that improve versus existing technology, or are we chasing technology that will never be competitive? And I would say we're currently going to a strategic planning exercise at DOE to address precisely that question and see if we can optimize or improve our portfolio in technology, and we'll always try to do so.
I have a situation in Kingston, Tennessee, that perhaps everyone in this room, or certainly if you watched TV in the last year, would be aware that there was a huge ash spill at the Kingston steam plant. We are told it will probably cost close to $1 billion plus for that cleanup that will go on the bills of almost 8 million users in the Tennessee Valley to help pay for that cost. That's a substantial amount of money that we have deferred for the last 30 or 40 years. And so as we engage in this debate, it is my hope that we look at every situation, alternatives, renewables, and others, about whether or not this will help us get away from that situation. I asked the TV officials and others, if we were to take that $1 billion and build a solar farm in Tennessee, what percent of the energy being produced at the steam plant could we produce for that $1 billion investment? And I'm told somewhere between 12 to 25% of energy that would be a renewable source, and all we do is take Windex and clean off. So as we engage, the reason I asked the question and made the comment is that as we engage in this conversation, it seems that we, from time to time, don't look at the actual total cost and what the cost will be to us 10 years, 20, 30 years, or 40 years down the road. I hope as we engage in this debate, and as we continue to have hearings here and in other committees in the House, that we become a little bit more focused on the proposals we're making. How successful will they be, or is this just a new concept or idea that may or may never work? Thank you all, and thanks, Mr. Chairman, for having the hearing.
Thank you, Mr. Davis. Mr. Ehlers.
the waves. And the Great Lakes are big, but they're just not as big as the Pacific Ocean. And there's no tidal energy. There's no current flow. Now there is potential locations where the lakes flow when the water flows out of the lakes, like they do, I know, in upstate New York, for using hydrokinetic energy. So I wouldn't look in the lake, but I would look where the water flows out of the lake.
Yeah. Okay, thank you. Also want to mention, getting back to my comment about renewable energy, this is really solar energy, and we might as well identify the source correctly. I think solar has immense possibilities in many different manifestations. But when you mention solar, people automatically think of photoelectric cells and things like that. But there are tremendous opportunities created by the wind. And this is just another manifestation of that. The comment was, you've talked about low head. How big is a low head? I mean, when you say low head, I immediately think of submerged restroom, but I don't think that's what you're talking about. How big a head is low head?
Well, low head in the context that we're focused on would be a drop across a structure that is less than 20 feet, but in general greater than 5. And the reason for the cutoff at 5 is just when we run economic analysis on a number of sites, once you get below 5 feet, it just is very, very hard.
Mm-hmm. And a lot of effort appears to be going into developing appropriate turbines for this. Is that the best way to get energy, or can you just anchor the generator to the ocean bottom and the up and down motion of the waves? Is there any possibility of somehow extracting energy from the up and down motion of the waves rather than the lateral motion? Any comment on that? Mr. Bedard?
Yes, there are many different ways to convert either the potential or kinetic energy in waves. Many of the devices do work by using totally the potential energy, the up and down motion of a floating buoy that's then reacted either to the bottom or to a reactionary plate, which is submerged in the water column. So yes, many devices work through the up and down motion of the.
And which appears to be most promising at this point?
You know, we are not far enough along in the technology to know which of the different energy conversion devices will turn out to be most cost effective in the future. Wind has obviously gotten there. You look at the wind machines; they're all open rotor, 3-bladed, machines on a monopile. But with wave energy, we're just not there yet. We need to test and evaluate the different energy conversion devices first.
Thank you very much. Yield back.
Mr. Ehlers, thank you. Mr. Tunkel.
Thank you, Mr. Chair. And good morning to our panelists. And Mr. Bedard, thank you for mentioning the turbulent flow of waters in upstate New York. That's part of my district area. Prior to arriving here as a freshman this year in Congress, I served as president and CEO of NYSERDA, the New York State Energy Research and Development Authority, which, as you know, had the demonstration project along the East River, along the island of Manhattan, with Verdant Power's project. And they did disassemble that project for improvements that were sent over to the Colorado lab of DOE, and I believe we're back up and running. We're not. Okay, we're supposed to be. But anyhow, I just want to know what Snohomish, perhaps Mr. Collar or Mr. Bedard or whomever on the panel, might address your comments to what might have been learned from Verdant Power's project in that East River demonstration.
Certainly. I think there were a number of things. First of all, you really have to applaud Verdant, I think, for the effort really blazing the trail here in a lot of ways for efforts like ours. Say again? Yes. Yep. So, I mean, a couple of things that were learned were in terms of deployment methodology in relatively shallow water. Folks might assume that this would be a relatively simple and straightforward evolution. It's not. It's very difficult even in places like the East River. So there was some learning there, obviously, in terms of the robustness and the design of the turbines themselves and the blades in particular. You're going to have some failures like that along the road. So, learning from those and sharing that learning through efforts like the DOE's programs is important and has occurred. And then last, I think we also learned a fair bit in terms of monitoring technologies for monitoring the interaction of fish and marine life with turbines like the Verdun turbines, specifically in that case using the biosonic hydroacoustic technology. There were some parts of that worked really well, and there were some parts that we would choose to do differently in the future. So those would probably be the top three things that I would point out.
Mm-hmm. As I understand it, it was not just the blades of that design, but also the assemblage of the blades that had to be improved upon. Mr. Bedard, were you going to comment on that?
I was going to add, sir, that Verdun completed their experimental phase about 6 months ago, and they took the 6 units out. They got lots of good environmental data. They have now filed a draft license application with FERC to go to the next phase, which is an installation of 30 of the units, about 1 megawatt of rated power, and so they will be in the regulatory process now for another year or 2 years before they hopefully get the license to install their next generation of turbine in that same location between Roosevelt Island and Queens in about 2 more years.
Right, and it was interesting to see what that meant to the Roosevelt Island population with some of the power that was exchanged for them. It's hoped that as much as 1,100 kilowatts worth of power could be utilized in kinetic format in New York State. So, you know, it's rather encouraging to see the promise that it holds. And in terms of the PUD plan here with Snohomish, what are your plans to interconnect the tidal project to the main grid?
Yeah, we actually intend to connect on Whidbey Island, which is adjacent to our site. Specifically, we're working with Seattle Pacific University. In fact, their marine science lab is right on the shores where we would tend to interconnect. So currently, we're in dialogue with them about rebuilding their marine science lab into one facility that can both serve their educational purposes as well as our need for onshore infrastructure, and provide them with a pretty neat educational opportunity to leverage the results of our project to fulfill their mission.
Thank you. Thank you very much.
Thank you very much, Mr. Chairman, and I'm sorry I missed the first 3 witnesses. And Mr. Bedard, I remember JPL and...
Yes, sir. I worked on...
Right.
I worked on Mars rover.
I remember.
back in the late 1980s.
I remember visiting you there once, I believe. And I don't think the question about cost was answered correctly, fully. I'd like to, obviously, if we're developing an energy resource, it has to be of competitive cost in some way, or it's just, we're just playing games here. So we don't create technology in order to create technology. So it's going to be integrated into an energy system that has other factors as well that have costs. How will this, once we develop these technologies that you're talking about, how competitive will it be as compared to other sources of electricity?
The technologies we're working on, I believe, can be in the 10 to 12 cent per kilowatt hour range. And we're pretty confident on those numbers. It's really a function of how much steel goes into the machine versus how much power you get. Yes, you have costs for mooring and that sort of thing, but that's the main driver. And
how would that be interpreted in terms of oil would have to come to a certain barrel price in order to permit the electricity for you to be competitive with electricity? What would that be?
Well, carbon fuels are in the range of about 4 to 7 or 8 cents per kilowatt hour, but that is without counting the external costs.
Right.
So if you give credit for that, which was a point that came up earlier, these technologies would be competitive.
Okay. One of the things that I've noticed, seeing that I live along the coast and I spend a lot of time in the water, that, although that's the case, I've also been a supporter of offshore oil and gas development, that wealthy people tend to live near water, and they tend not to want to have their view disturbed, and their view is more important than energy for the people. Would your alternatives create a view problem for people?
Certainly, wind provides a very strong visual impact, but what I think I've been saying anyway is that people now are starting to understand that there's priorities beyond the view aspect.
I would hope so. I would really hope that some of the people who are the most have really enjoyed the fruits and benefits of our society would be a little bit more considerate of everybody else rather than just worrying about their view. Seeing that we have about $1 trillion worth of energy in terms of oil and gas that we should be utilizing offshore, but I would hate to see situations like great alternatives in the future. Look, 100 years from now, whether it's 10 years from now or 100 years from now, the type of ideas you're going to bring up are things that mankind is going to have to depend upon. And you may be exploring an area that is really, 100 years from now, we may get vast amounts of energy from what you're doing and might be dependent upon that far more than we are in oil and gas. I would hope so. That's correct. So, Mr. Chairman, thank you for your leadership in this. I see this as a visionary approach, which I think that we should be exploring, and I wish you all success.
Thank you for your observations and insights. Mr. Inslee is recognized. Thanks for joining us today, Mr. Inslee.
Thank you, and thanks for Mr. Chairman for holding this hearing. This is something we're looking in the future, and I appreciate your willingness to explore this. It's something that hasn't totally arrived commercially, and your willingness to do this I'm very appreciative of. I'm also appreciative of Mr. Eller's insight that all of this is solar power except nuclear and engineered geothermal. I think that's a great insight. He's the only other congressman that I've heard share it other than this one, so thanks, Mr. Ellers. Mr. Collar, welcome. And Mr. Dehlsen, I want to thank you for being the personification of what I view as a dynamic here, which basically is following wind into the water as far as the dynamic, the economic dynamic. You're the absolute personification of that. You may not remember, but you and I spoke a couple years ago when I was writing a book, and you told me about an interesting story about Clipper Wind and the development of wind power, about a bolt that broke. And do you want to share that? It's kind of a metaphor for what we're talking about here. You remember this story? You told me.
Well, I remember one in the very beginning of wind power, and it was the first wind conference in Palm Springs, and there was a lot of excitement around a machine that Bendix had put out that was a Darius machine, looked like a big egg beater. Everybody had gathered out there to watch the machine perform. A bolt gave out. And fortunately, it could have decapitated the whole crowd, but that was one of the kind of the early lessons on structures and how these things have to really have pretty rigorous kind of engineering.
Well, I appreciate the story, and the reason is despite that failure, the industry is now very commercially viable and robust, and is the most dynamic thing in the energy industry probably right now. And I sense that that's the kind of experience we're going to have in the hydrokinetic field. You said something that was interesting, that you were optimistic about this, and maybe it was you or Mr. Bedard, I'm not sure, that the density of energy associated with water as compared to wind may give this industry a faster uptick than wind. Do you want to elaborate on that? Whichever one of us you said that.
Yeah, that was myself, Mr. Inslee. And the point I was making was that the fact that the power density of the hydrokinetic resource much greater than that for wind and solar, that allows smaller machines with less material, and capital cost is there's a potential capital cost advantage of a hydrokinetic machine, say, compared to a wind or solar machine. But there's another side to that coin, and the other side is that it's operating in a very remote, hostile environment. So the challenge to the marine hydrokinetic industry is going to be to develop the deployment technology and the operation and maintenance technology that will allow the total life cycle cost to be less than or competitive to other renewable sources.
Thank you. Mr. Beaudry is at Losique, and I'm sorry, I can't, if that's the correct pronunciation. We were so far a little bit disappointed in the stimulus funding. We haven't seen any of the stimulus funding dedicated to this particular industry. Do you have any insights on that? Do we have some hope in that regard?
I would say the Recovery Act mandates were fairly specific. The focus was on creating jobs that would have short-term impact. Regarding the allocation to water budget, we felt that traditional hydro projects could be put in operation fairly shortly, and that there was no truly immediate device that was ready to go at a commercial scale for marine hydrokinetics, and that our R&D budget for hydrokinetics, for example, is fairly plentiful right now, and we have what we need.
Well, we'll continue to try to provide you some additional resources, and I'm appreciative of the vision that the department has shown and hope it will continue. One of the things I've introduced a bill, and we're looking forward to a reintroduction of a bill that would establish a dedicated department really for this particular technology in hydrokinetic. I think it would be helpful in focusing, and the reason I note that is I think almost all of the witnesses talked about the importance of stability in federal policy, of a long-term federal commitment that is not dependent on the personnel that happens to sit in a particular chair for 3 or 4 years. It's not dependent on who the majority is in Congress, but it's a long-term federal commitment. And I think the establishment of an office would go a long ways to helping in that regard. And I look forward to talking to members and the chair about that. Hope we can advance that. Thank you very much.
Thank you, Mr. Inslee, and thank you for your many years of leadership on not only this particular form of energy, but the whole issue of alternative energy and your book, which you brought with us. What is the title of that book, Mr. Inslee?
Well, I appreciate your efforts, but I don't know if I can put you in the 5% plan for marketing, Mr. Chair. I appreciate that.
Mr. Inslee wrote an outstanding book, Apollo's Fire, and it's an outstanding compendium, a bit dated because the transitions are happening so fast, but very few members of Congress know as much about this topic as Mr. Inslee, and thank you for your leadership on that.
If I can note, though, I just want to note, Mr. Dehlsen was one of the most interesting people I met in the production of this book, and I remember very specifically getting to talk to him about this story. And Mr. Dehlsen, I want to thank you for your leadership now in multiple technologies. We really appreciate it.
If there are any other members wishing for me to plug their books, I'm happy to do that at this point. Let me follow up. I'd like to do a brief second round. We may have some votes coming up. Mr. Beaudry-Losique, we've heard a lot about this issue of permitting and regulatory structure. Has your operation sat down with NIMS and the other regulatory bodies and said, how can we work together? What changes do you need? How do we make those changes happen? And if you haven't, can we do that?
We are working with other agencies on a lot of our different renewable technology. I would say this is a problem that's not unique to marine and hydrokinetics. It is shared by offshore wind. It is shared to some extent with solar deployment on BLM lands. This is shared by on-land wind as well. So we've had a numerous discussion with the Department of Interior, with FERC. Within the Department of Interior, we're working specifically with MMS, which has a lot of the jurisdiction offshore for speeding up permitting, both for offshore wind and for marine and hydrokinetics technology. We hope to have a MOU in place with them shortly. But I would completely agree with my fellow panel participants that this is a very serious issue and that we're putting a lot of resources against it. Furthermore, we're doing a lot of the environmental studies to help pre-permit these marine research energy centers so we can have test bed to plug in small-scale marine devices fairly quickly. And that's part of our funding is actually to establish that pre-permitting that would help speed up testing these technologies?
I've done a lot of work on the permitting issue back home because we've got a lot of water and a lot of endangered species where I live. And one of the things that really seems to help is to get all the agencies in a room with the consumers of the agency services, i.e. the permit applicants, and then try to see if you can't come up with some standardized permit structures. You know, back home, it's not the first time a dolphin has ever been put in. I don't mean the swimming dolphin. I mean the things you moor a boat to. It's not the first time we've ever put one of those in the Columbia River over the last couple of centuries, and yet there was a long process where each time you had to do a brand new EIS as if nobody had ever done it. So they've now got streamlined mechanisms for that. So my question would be, has there been a meeting, a conjoint meeting of your operation within DOE, the tidal hydro side, with the multiple regulatory agencies, with the applicants together to say, let's figure out how to do this, come up with some target timelines, some reasonable expectations for baseline and follow-up data, et cetera, particularly as we try to set up this test bed. Has that happened yet?
I would say it's fair to say that there has been a series of bilateral discussion with key agencies, and it's definitely on our work plan. For example, we, DOI and MMS, get all the agencies in the same room in a working group with applicants to help determine what are the best intervention points to speed up the permitting process. But this meeting has not occurred yet.
Okay. Well, I'll ask the witnesses, would that make sense to have a meeting like that? Would that be helpful to you?
I think from our perspective, it certainly would be very helpful. I think it's a logical next step. It's something we have not done to this point, and I can see where it could be pretty useful, yes.
At approximately the same stage in wind, going back in the early 80s, what was done in a number of counties was to designate zones. And so rather than each time a developer having to go through the process, just approving a zone would be extremely helpful.
Okay. Mr. Bedard?
I'm fortunate enough, Chairman Baird, to work for a technology organization, and I don't have to get into the permitting. In fact, when I had my 3 children and needed a larger house, I even avoided adding a room on and going through the permitting process. I just bought a new house. So I don't like to deal with the pain.
Ms. Schneider? I mean, I know your issues are somewhat separate, but perhaps you've got some insights.
Yeah, I mean, yeah, in the sense of creating, especially as you look to low-head applications in stream, it's the same general concept applies in terms of gathering standardized information and then feeding that into a streamlined process with FERC. Not just the resource agency side of things, but also then moving on to FERC. One of the things, I mean, we certainly actually had a reasonably good path, I guess, through the process on this first project. But that's also because we put a lot of effort in up front, talking to all the stakeholders involved.
Shifting topic a bit, Dr. Ehlers called much of this solar power. I believe some of it's lunar power as well, is it not?
Yes, there. Yes,
I think Puget Sound, my guess would be the Admiralty Inlet source is a fair bit lunar power. That's a lead-in, actually, to a more substantive question, which is, Dr. Bedard, you talked about wave energy being the most promising. We've got a lot of big waves off our coast, and I'm glad to see that's been recognized. But it seems to be the more predictable source is tidal flow. And we know when it's going to happen. We know its velocity. When I scuba dive up in that area, man, you literally start it to the minute in some of these dives, because if you're not out of that water when that tide changes, you've got a real problem up there. So we know to the minute, and that's not the case with wind. It's not the case with even solar in many cases, and it's a real problem up in the Northwest as we try to integrate grid with unpredictable sources. Yet tidal's probably more predictable than wind. What's your take on that? Not more. Yeah, I think it's clearly more predictable than wind. Probably more predictable than wave as well.
Yeah, it certainly is. Matter of fact, one can predict the tidal speeds centuries in advance because they're totally dependent upon the relative location of the Earth, Moon, Sun system. With waves, it's also a good situation in that the waves are created from storms in the Pacific Northwest off the Japan, the Gulf of Alaska. So we know 3 days in advance before the waves are going to hit the beaches. Mr. Rohrenbach, who's a surfer, would know that the Maverick competition at Half Moon Bay, they call in the expert surfers one day in advance before the biggest waves are going to hit. So that definitely the predictability is definitely an advantage. When I said that wave is the most significant, in the lower 48 states, there's only maybe a handful or a dozen or so really good tidal sites. Most of the ocean energy state in our country is the state of Alaska. They have by far the most wave and tidal resources.
But we've got off, I mean, actually a little bit north of us, but off Vancouver Island, there's some hellacious, and in Point Defiance.
Absolutely.
It's pretty, I almost said whitewater kayak. I sea kayak there, and it's like whitewater kayaking at times. It's pretty exciting.
I'd like to offer another source of energy, and that is the rotation of the planet and the Coriolis effect, which drives the Gulf Stream. And the energy resource off of southeastern United States by the Gulf Stream is quite enormous. It's equal to about 50 times the rivers of the planet, and it flows 12 to 15 miles off the coast of Florida, which doesn't have much else in the way of renewable energy, no geothermal, et cetera. So that is a very important one, and technology for doing that is very much like what you see coming out of wind power. So that's the area we're focusing on, actually.
Great.
That and wave power.
Thank you. I one last comment. I drove by San Francisco Bay a while back and saw all those ships moored way up the bay there. They're permanently moored there, and I thought, Archimedes tells us there's an awful lot of weight being lifted every day. And lowered back down every day and lifted every day. It's too bad we can't attach that to some kind of generator. Maybe somebody bright sparks figured it out. Mr. Inglis.
Thank you, Mr. Chairman. I think, Dr. Ailes, you want to? Sure.
I'm going to get a lecture on Archimedes here, but that might be
No, except that apparently there's no historical evidence that he ran through the streets naked shouting Eureka.
That was my favorite part.
I know. It's most everyone's favorite part. No, I was just going to comment on the Gulf Stream. I'm very afraid of tampering with the Gulf Stream because we don't know how stable it is. And it would be disastrous for Europe if our attempts to extract energy from it somehow interfered with the flow of the Gulf Stream. And I have no idea what, I just don't know what the tipping point is, and I'm not sure anyone knows. So I just wanted to toss that in.
Could I respond to that? We have.
Hey, let me recognize Mr. Inglis for his 5 minutes, and Dr. Ayers will get his shot. Unless Mr. Inglis wants to hear about the Gulf.
That'd be great. Answer that question. Yeah, I'd be happy for you, Miss, to answer that question.
We have the University of Delaware do a study on that topic, and their conclusion was that at 10,000 megawatts, it was essentially within the noise of natural variability. So effectively, you could extract that from the Gulf Stream, say off of Florida, and really have no impact on the on that circulation pattern. That's a very important topic to be aware of.
Yeah. Just two observations. One is, as a guy that's into sailing, I think that these the scene of being able to see wind turbines offshore is like looking at sailboats, and for the well-heeled that Dana was speaking of that don't like their view shed interrupted, I think you just need to rethink that and just imagine that that's a beautiful sailboat out there. In fact, maybe we could put some colorful sort of spinnaker kind of sails on them and or ribbons and make them look more like sailboats. I think they're really beautiful, particularly when you think about how they're out there producing no emissions. They're a rather beautiful scene. You should invite people over to see out of your window what we're doing out there, seems to me. The other thing, since we're plugging, and I'm not plugging a book, I'm plugging a bill. I mentioned earlier Carlos Gutierrez's definition of sustainability, that is making a profit. The challenge we hear from this witness table a lot in transportation fuels is that the incumbent fuel there, being petroleum, doesn't have all the cost in. If the costs were all in their proper cost accounting, even for the simple thing of the defense expenditures associated with protecting that supply line, even if that were only attributed to the price of petroleum, then a lot of what we hear from that witness table would become economically viable. What we're hearing today is that this wave energy, tidal energy, could become viable if the costs were in on coal, the dominant incumbent technology. If all the costs were in there, wow, you'd be in business. So these ideas would not be ideas, they'd be actually being deployed and being developed. So I got a bill that does that. It's 15 pages compared to cap and trade, which is a 1,200-page monstrosity. It's 15 pages of a simple concept of a revenue-neutral tax swap, reduce payroll taxes, impose a tax on emissions, make it border adjustable so that it's removed on export, imposed on import. It's pretty exciting. 15 pages gets the job done. And it would change the economics and make us so what we hear from that table would suddenly become viable and fit with Carlos Gutierrez's definition of sustainability. If you can make a profit, it's sustainable. If you can't, it's not. But with the incumbent technologies, get to hide the cost with negative externalities that are not internalized. There's a market distortion, and especially conservatives should rise up and say we can't tolerate market distortions because we believe in the power of markets. We believe in the power of free enterprise. So thank you, Mr. Chairman, for that opportunity to plug my bill. It's a book.
I fully support your bill, and the only drawback is that it sinks less carbon in the text of the bill than does the competing cap and trade model. But I think it's a much more elegant and likely to succeed strategy than the cap and trade model. But the key point, though, is to make this technology work, you've got to truly value carbon in some fashion. And I think yours is a better way to do it, frankly. Dr. Ehlers.
Thank you. Very briefly, I totally agree with the comments of Mr. Inglis, and it's certainly a more intelligent approach to take to the cap and trade, and simply add a tax and give the money back to the people in a different way. I also commend Mr. Inglis on his comments about the view, and I decided after your discussion of how beautiful they are that you obviously could improve your salary by beginning to sell real estate. You have a real talent there for making property look good. With that, I yield back.
One final topic. The bells imply that we have a vote. We have not talked about thermal potential within the oceans, and I wonder if any of you would like to chat about that briefly. And it may not be within your purview, but possibly Mr. Beaudry-Losique could talk a little bit about the thermal potential energy, because I understand it's fairly significant.
And we agree that the potential of ocean thermal is fairly enormous. However, because of the relatively low difference of temperature between the top and the bottom of the ocean, we need still fairly large-scale enormous devices with very high capital costs. So we're going to spend the next year or two to try to validate the economics of OTEC and try to and work also with the Navy on that topic and try to determine what is kind of the ultimate potential of driving that cost down, and then therefore that will drive where would it best fit, either in tropical island or for more mainstream applications.
Yes, and with the Gulfstream application, what the machine that we're developing is one that can also, other than generating electricity, you can generate high pressure water to shore and use that water for reverse osmosis desalination. Because you're drawing the water off of depths, you pick up about a 20-degree differential. So central cooling of Miami, for example, is a possibility, and the energy payback on that is enormous. If you combine the residual electricity that you could generate off of the reverse osmosis flow that remains, plus the central cooling, it really helps significantly in the economics of that technology.
Maybe some low-head hydro applications there as well, I would guess. I want to thank our witnesses for very, very fascinating work, and for actually, in all of your cases, lifetime of contribution to this important issue. As always, the record of this hearing will remain open for 2 weeks for additional statements from the members and for answers to any of the follow-up questions the committee may ask of the witnesses. I would like personally to maybe follow up with some of you about the idea of joint meeting with some of the regulators, some of the applicants, and the research side, so that we can possibly get this thing moving a little bit faster, maybe a lot bit faster. And with that, the witnesses are thanked for their time. My colleagues, thank you for your input as always, and thanks to the staff. And the hearing is now adjourned. Thank you very much.
That was fun. Yeah, that was fun.
Very brave.